All right. Now let us start with building the agents. The first agent that we're going to build is supervisor.py. Now, if you actually go to this particular agentic pipeline, you can see supervisor agent. And typically, if you look at the other agents, all 6 agents are working in parallel. And supervisor agent, the only job is to route the task. Okay. It activates different specialists and it is going to compile the brief or whatever output they're going to give. So supervisor is nothing but it's an orchestrator of the entire pipeline. Its first job is to route, which is it is going to use something called a supervisor route, which means it is going to read the incoming task, it is going to prepare the shared state, and it is going to hand off, which means it is going to delegate the task to 6 agents. Okay, you can think of this as a project manager who reads the client brief and understands on investigating to whom should it assign the task. The next job is to compile. Okay, so after all the 6 specialists finish, okay, it will read every signal, okay, they found, it will rank them by priority and write one intelligence or final intelligence brief. You can think of it as project manager collecting everyone's findings. And what the supervisor does not do, supervisor does not analyze the study itself, it does not call any tools, it does not search the database, its only job is coordination across all the different agents. We're going to use UUID, we're going to use chat OpenAI, we're going to use human message and system message, which is human message is prompt given by the user, system instructions, system message is system instructions. We're going to use the state from graph.state, we're going to use the mosaic state and the signal output that we have defined. Okay, first and foremost, we start with defining the LLM instance. We pass the chat model we're going to use, we set the temperature to 0.1, which handles the randomness, and we're going to take the API key into consideration. The first function that we're going to define is supervisor route. If you can just go back to graphbuilder.py, you can see all these routes being created. These routes are nothing but these are nodes in your agents, okay, or your graphical workflow. And this is the first node in the LangGraph agent or the LangGraph graph. It runs before any specialist agent, and its job is to initialize and prepare the state for a specialist agent. You can see it is async in nature. Supervisor route, it takes the state into consideration and gives an updated state. Okay, this is the entry point for the entire agentic pipeline. What does this function do? It generates a unique run ID for the analysis session. It logs what task is being investigated, and it returns an updated state that all the specialists will receive. Okay, why so simple? The supervisor does not need to read the task and decide which specialists to activate. We always run all the 6 specialists in parallel for every tasks. Okay, all right, cool. So you can see first and foremost you are giving run ID, which is UUID. Okay, we're going to log it, which means the supervisor is routing. This is the run ID, this is the task. And where do we get the task? From the state we're going to extract the task. If nothing, then just an empty just an empty string, and we're going to take the first 80 characters that prevents the long description of the task. Okay, what does this supervisor route return? It returns the run ID, which agents are activated. Okay, as of now it's empty. By the end, this list shows exactly which agents were activated. Signals, which means what outputs were generated. Okay, and this signals are just appended into the empty list. Is the run complete? Yes or no? As of now, false means the run is in progress, and true means the run or the complete work is done. And error logs, if there are any errors, that is also going to log it. Second node is the supervisor compile node. It again takes the state from the above, it takes the state from the above node and gives an updated state. What does this node do? This node is going to read all the agent signals or the agent outputs and compile them into the final intelligence brief. When does this run? LangGraph calls this node only after all the nodes have completed, and this is the guaranteed. This is guaranteed by the graph structure in the graphbuilder.py. What does this function do? It is going to collect all the signals from the state, which is from all the 6 agents. It is going to separate high confidence signals from those requiring the review. Review are the ones which have low confidence threshold. Then it is going to use the LLM to write a professional intelligence brief, and it is going to return the completed updated state. And why use GPT-4o to write the brief? The raw signals are structured data, right? JSON, the raw signals are what? They are what? Structured data. So JSON with the fields like summary, confidence, and city ID, etc., they are accurate but not readable. So GPT transforms them into a readable narrative. So from the state, we're going to extract the signals that we're going to populate here. Then again from the state, we're going to extract which agents are activated. And from the state, we're also again going to extract task. So these three things we're going to get populated here. We're going to log it. If there are no signals, it is just going to, it is just going to say that no signals are found. And it is going to return analysis complete, but no significant research integrity signals were detected. Okay, because obviously nothing, we are getting no signals. We're going to separate signals by the review status. Okay, I'm just going to iterate over all the signals. We're going to, from that S, we're going to get the confidence, and if the confidence is greater than 0.6, then that particular signal is a high confidence signal. Okay, then we're going to look at the review signals, which means the ones which are queued up in human in the review. If their confidence level is low than 0.6, they are basically the ones that are with low signals, or sorry, low confidence levels, which require human in the loop. We're going to format the signals. So we're going to use this function, format signals for LLM. We're going to take the signals, we're going to apply this method, and we're going to extract, store it in signals text. Okay, so we're going to convert the list of signals dictionaries into clean text block. Okay, all right. Here is the system prompt that I've defined for GPT-4o. If you see here, you are a chief intelligence officer for Mosaic, a clinical trial research integrity system. Your job is to compile a professional executive brief. This is the format to be followed, how the tone should be, all of that I've defined. Then at a human prompt level, it takes the analysis task. It takes the signals that is found by agents, that is the outputs of the agents. It takes the high confidence, how many high confidence signals are there, how many signals are requiring the review, and how many agents are activated. It takes all those agents separated by comma. And please compile the final intelligence brief now. So you can see as of now, what does it do? It calls the LLM, it invokes the LLM. It takes the system prompt, treats that as a system message, takes the human prompt, treats that as a human message, okay, and generates the response. Why are we using response.content? We don't want, if we only write response, we're going to get the content as well as metadata. We don't want the metadata, and hence we only writing response.content. That gets stored as final brief. We're going to log that brief. If there is any exception or if there is any error, it is going to catch that. Finally, what does this particular agent return? It returns a final brief, which is the complete intelligence brief. It suggests if the run is complete or not, how many signals generated across the agents, are the signals requiring any review, like how many signals are requiring review, and what all agents got activated. And finally, the private helper function which we applied, at the top, which is format signals for LLM. Yeah, what does it take? It takes a list of signal outputs. It takes the list of signal dictionaries, okay, into a clean readable text block, okay, that GPT-4o can summarize into a final brief. Okay, so here, if there are no signals, it is just going to say that no signals generated. It is going to create an empty list called as lines, okay, which is which is going to append here. We're going to iterate now on signals starting at 1, okay, and from lines, which is going to append like which signal, agent, type, NCT ID, and confidence. All these details are going to get appended to this empty list, which is lines, okay, as well as summary. Yeah. Finally, what does it return? It returns lines which contains all this data. And all this data gets fed. So when we apply this function, format signals for LLM, when we are applying function, what does formatting signal mean? It means all this data will be taken into consideration, right, from signal, agent, type, NCD ID, confidence, summary, all of it. Okay. Then one more helper function, fallback brief, which takes a list of signals, which all signal agents are activated, and the task. What does fallback brief do? It generates a basic structured brief without using a GPT-4o. Okay, so that is what it is doing. Is it required? It's completely your choice if you want it. If you don't want it, that's also totally fine. And this is called when LLM call fails, which means just to ensure that the API always returns something useful even if the OpenAI API is down or rate limited. This is just another fallback mechanism that we are doing. Okay, you can see this empty list. Okay, so just how above we had lines named empty list, here it will be having executive summary, analysis complete, signals by priority, all of that it will be appending it here. Okay, you can see it is going to append from the signal, it is going to get NCT ID, it is going to append it there. From the signal, it is going to get signal type appended there. From the signal, it is going to get summary, it is going to append it to lines, and it is going to append confidence, all of that. Okay, it is going to, we basically are going to hard code and append all of that. Okay, so in case if we are working with API, or if the API is operational, format signals for LLM will work fine. If the API is down due to some reasons, we have a fallback mechanism, which is fallback brief helper method, which will give us some intelligence brief, right? So that is fantastic. Okay, now after supervisor, let's move to building next agent.